All right, we're back. We are in Calc AB Notes 8, talking about L'Hopital's rule, doing a lot of limits, trying to get the notation correct. And we're going to be on page 4 here, so let's just keep going because it's just more examples. So this first one's kind of interesting because, so let's think about it graphically. Natural log of x looks kind of, but not exactly like this. So I know that the limit as x approaches 0 from the right of the natural log of x is negative infinity. So that's interesting in part because the limit as x approaches 0 from the right of x is not negative infinity or infinity. It's actually 0. This is not an indeterminate form. The question becomes, what's actually happening, right? So let me also graph y equals x. So this will be a sort of garbage graph of just y equals x. I guess I'll say y equals x. You know what? Let's say g of x. G of x is x. G of x equals x. And let's rename this fancy guy f of x. And now we have f of x over g of x. Okay, so the limit as x approaches 0 from the right of g of x, which is just x, which is actually more writing, is 0. So we actually have negative infinity divided by 0. So what happens here? This limit doesn't exist. And you could probably just say this limit doesn't exist and like move on with your life. But what does it tend toward? Well, the easiest way I think to think about this is that this part right here is definitely going to negative infinity. Now the denominator is going to 0, but it's going to 0 through tiny little positive numbers because, so approaches 0 through the positives because we're approaching 0 from the right? So 0.1, 0.01, 0.001, and whatever. So we're doing negative infinity divided by an infinitely small positive number, basically. The reciprocal of an infinitely small number is an infinitely large number. So I tend to think of this as this is a very informal way of thinking about it, though. I think of this as like negative infinity divided by 1 over, like essentially infinity, right? That's basically where we're going to get 0 from. And so that's negative infinity times infinity. So the answer here is actually negative infinity. This is not a L'Hopital's problem. And that's kind of interesting. So I thought about it graphically. You could have probably just said does not exist and like moved on, but I'm never happy with does not exist as like my final answer for a limit. I always want to know, what does it tend toward? Like, why doesn't it exist? All right, let's see. We're going to say the limit as x approaches. So I kind of don't want to name it because I know what's going to happen on this, and it's going to be like a little extra work. So I'm just going to go for it. The limit of the top here is that definitely 0? So I get e to the first is, e to the 0 is 1 minus 1 is 0 minus 0. So 0 over, the limit as x approaches 0 of x squared is also 0. So therefore, can I squeeze it in here? Nope. Therefore, by L'Hopital's rule, the limit as x approaches 0 of e to the x minus 1 minus x over x squared is equal to the limit as x approaches 0 of, let's use L'Hopital's rule. So the derivative of the top is actually just e to the x minus 1 over the derivative of the bottom, which is 2x. What's happening here? This is so annoying because the limit as x approaches 0 of e to the x minus 1 is equal to the limit as x approaches 0 of 2x equals 0. We're going to do it again, right? So we tried to do substitution. It didn't work out. As soon as it doesn't work out, do it again, right? So because we got 0 over 0, we're allowed to do this. We got 0 over 5, it'd be 0. If we got 5 over 0, it would be does not exist. But 0 over 0, L'Hopital's. So therefore, by L'Hopital's, again, the limit as x approaches 0. So I was like not looking forward to doing this one with the proper work because it's just a lot of work. Limit as x approaches 0 of the derivative of the top is e to the x. The derivative of the bottom is 2. This is good As soon as the derivative of one of them is clearly not 0, you are definitely going to get an answer. The answer that you get might be does not exist, might be infinity, whatever, but it's going to be an answer. It's not going to be indeterminate. So here I get 1/2. So that is our limit. A lot of work on that one. I feel like that might keep happening, even though I don't want it to. Let's take a look at this one. All right, so I always kind of informally in my head, like really quickly, just evaluate the limit. So I'm definitely like thinking this is 0 over 0. So I need to write my work. And I can also like, you can see into the future. If you like picture yourself taking the derivatives, like we're gonna get cosine type thing, and a secant type thing. Are we gonna have to do it more than once? Maybe, I don't know. Limit as x approaches 0 of x minus sine of x is definitely 0. And then the limit as x approaches 0 of x minus tan of x is also 0. We're going to L'Hopital's, therefore blah, by L'Hopital's. The limit as x, I mean, it takes all the fun out of doing them. And definitely in my other videos that are just like in the playlists, I did not do proper work because it wasn't a thing. You didn't have to do it. Now you do. Most of them just a whiner about this. 1 minus cosine of x, so that's the derivative of the top. Derivative of the bottom is going to be 1 minus secant squared of x. Okay, so if x equals 0, we get, it's another L'Hopital situation. We get 0 over 0. All right, so the limit as x approaches 0 of 1 minus cosine of x is equal to the limit as x approaches 0 of 1 minus secant squared of x. Seems like overkill on the work front, but whatever. By L'Hopital's. Let's hope it doesn't go again. The limit as x approaches 0. So one of the things, like, I like to do the work with you because then we can all complain together. And also you can't say that, you can't say you're not willing to do it because I am, even though I'm going to complain all the way through. All right, the derivative of negative cosine is positive sine, which like might be a good sign because the sine of 0 is 0. So like maybe we'll get an answer here. The derivative of the bottom, this is a chain rule situation. So the derivative of 1 is 0, that's gone. So I'm going to get negative 2 secant of x times the derivative of secant. So negative 2 secant x times the derivative of secant, which is secant x tan x. Like my fraction is not even long enough. Oh man. I think what I should do here is simplify. Right? I mean, this is actually 0 over 0 if I try to directly substitute, but I think a better thing to do is to use some of the properties of trig functions, some trig identity type stuff. So let me do it. Where can I squeeze this thought? So I'm going to get an answer, I think. So secant is actually 1 over cosine. So I'm going to do a little identity here. So I've got negative 2 secant squared, and then tangent is sine over cosine. So this is, the signs actually cancel. You end up with cosine negative. What do you get? I think you get negative cosine cubed over 2, right? Because secant is 1 over cosine. So that's 1 over cosine squared times 1 over cosine is 1 over cosine cubed. But it's in the denominator. So it's like 1 over cosine cubed. So it becomes cosine cubed in the numerator. The sign in the numerator and denominator just cancel. The negative 1/2 just hangs out. So I'm thinking that this is actually the same as the limit as x approaches 0 of negative cosine cubed over 2, which would be negative 1/2, which I'm like really uncertain about. But I don't know. Let's just check that one right now. Let's check these, and then we'll come back in another video, and we'll do the rest of the page. How does that sound? I mean, no one actually gets to say anything because I can't hear you, but limit. So remember, you should be using the template. It's just faster for me to type. X goes to 0 from the right. Negative infinity. Nailed it. Limit e exponential of 1 minus x over x squared as x goes to 0 overall, 1/2. Got it. This is the one I'm the most nervous about. Limit x minus sine of x over x minus tan of x. X approaches 0. Negative 1/2. We got it. You know, the thing that surprised me about that one, I guess, for whatever reason, is in my mind, I don't know why I feel this way. In my mind, I feel like both those functions should just like be positive for some reason, which like doesn't really make sense, I guess. But like sine, I think that x is above sine, and I also think that x is above. Maybe x is below tangent. Maybe that's what's happening there. So like what I'm doing, I'm going back to the calculator. So if you're done with this video, you're done. That's totally fine. In my mind though, I need to satisfy myself to this. So here's the graph of x. Here's the graph of sine of x. So sine is definitely below. So x minus sine of x is positive. Let's zoom box around this. So x minus sine x, definitely positive. I'm thinking if I had tangent here, it's going to be above. It is, but man, is it close. So that's why x minus tan of x is negative. So it makes sense that you would get a negative because you have like a positive divided by a negative. But I didn't have that intuition initially. And so my negative answer kind of like surprised me. But that's all right. That's what learning's all about. You know, you just gotta be willing to like go for it. So these are our answers. Okay. So I'm gonna stop this here, come back in the next video and finish the page and who knows what. So I'll see you then.